greatest integer function, also known as the floor function, the symbol, the floor of x is defined as the largest integer that is less than or equal to the given number x, wherein n is less than or equal to x. Now for example, we have the floor of 3.7. If we'll be going to find 3.7 in the number line, it can be found between 3 and 4. And as for the greatest integer function's definition, an integer should be less than or equal to the given number x. So since 3 is lesser than 4, therefore the greatest integer function of 3.7 is 3. Another one. Let's say the floor of negative 1.5. If we're going to plot negative 1.5 in the number line, it can be found between negative 1 and negative 2. Now in the definition of the greatest integers function, an integer should be less than or equal to the given number x. We have n must be lesser or equal to x. So since negative 1.5 is between negative 2 and negative 1, and between negative 2 and negative 1, negative 2 is lesser than negative 1. So the greatest integer function of negative 1.5 is negative 2. Now let's practice a bit. Can anyone tell me what is the greatest integer function of 7.9 and negative 0.7? Now, what is the greatest integer function of 7.9? Correct. The greatest integer function of 7.9 is 7. Why? Because 7.9 can be found between 7 and 8. And remember that all integer should be less than or equal to the given number x. So since between 7 and 8, 7 is lesser than 8, so the greatest integer function of 7.9 is 7. Now how about negative 6.7? What is the greatest integer function of negative 6.7? Correct. Negative 7. Why? In the number line, negative 6.7 can be found between negative 6 and negative 7. And we all know that negative 7 is lesser than negative 6. So the greatest integer function of negative 6.7 is negative 7. Next, we will visualize how this function behaves on a graph. But first, we will going to plot the points. But before we're going to plot the points, we're going to find each greatest integer functions. Now we have here 0 and the floor of 0. Now the greatest integer of 0 is 0. Now we have 0 and 0. How about the greatest integer function of 0.5? Yes, it is 0. So 0.5 and 0. How about the greatest integer function of 1.2? 1. So we have 1.2 and 1. How about the greatest integer function of negative 1.8? Correct. Negative 2. Now we have negative 1.8 and negative 2. How about negative 3.4? Correct. Now we have 3.4 and the greatest integer function of negative 3.4 is negative 4. Now, we have these pairs already. Now we can plot them. Now, the floor function behaves like this on a graph. Now let's try and plotting them together. Now we have here 0 and 0, which can be found here. Next, 0.5 and 0, which we could found here. Why not here? Because it is an open hole. So it goes back to left, which is still 0. Next, 1.2 and 1. 1.2 can be found here. But we cannot plot it together with an open hole. So 1.2 and 1 is our x and y pair. And so on, negative 1.8 and negative 2, as well as negative 3.4 and negative 4. Now let's do a quick check to reinforce what we've learned along the lesson. We have here some functions and we need to identify the given greatest integer function is true or false based on the definition and rules we applied from the previous activities. Now we have here greatest integer of 3 is 3, which is true because any integer n is equals to n. So the greatest integer function of 3 is 3 itself. So it's true. Next, we have the greatest integer function of negative 5 is negative 4. Is it true or false? False. Why? Because the greatest integer function of negative 5 must be negative 5 itself, because again, all integers or any integer n is equivalent to n. So negative 5, the greatest integer function of 5 is negative 5 itself, so it is false. Now we have 7.1. The greatest integer function of 7.1 is 7, which is true. Because 7.1 can be found between 7 and 8, and 7 is lesser than 8, so 7 is the greatest integer function of 7.1. And last, we have negative 2.5. The greatest integer function of negative 2.5 is negative 3, which is true. Because negative 2.5 can be found between negative 2 and negative 3. And we all know that negative 3 is lesser than negative 2. So negative 3 is our greatest integer function of negative 2.5. Now let's see how greatest integer function is used in real life situations. Now we have problem 1. A baker has 10.5 kilograms of flour. Each loaf of bread requires 2.2 kilograms of flour. Now how many complete loaves can the baker make? Now first, we have to divide 10.5 by 2.2. Since we need 2.2 kilogram each, bread requires from 10.5 kilograms of flour. So 10.5 divided by 2.2 is 4.77. Now, the baker cannot make a partial loaf, so we apply the greatest integer function to find how many bread can we make in 10.5 kilograms of flour for 2.2 kilograms of flour each bread requires. So the greatest integer function of 4.77 is 4. Therefore, we can 4 bread. So the baker can make 4 loaves of bread. Now let's proceed to problem 2. Now, you have 7.9 meters of ribbon. If each decoration uses 1.5 meters of ribbon, how many full decorations can you make? So, 7.9 divided by 1.5 meters of ribbon that each decorations needed is 5.27. But partial decoration are not possible, so we use the greatest integer function in order to round it down. So, the greatest integer function of 5.27 is 5. So, the greatest integer function of 5.27 is 5. Therefore, we can make a 5-fold decoration from a 7.9 meters of ribbon. Now, how about problem number 3? A car rental costs $45.50 per day. If a customer rents a car for 4.8 days, how many full days will they be charged for? We will only consider the full days the customer will be charged for, since that was what is being asked for. So the customer rents the car for 4.8 days. So it means they will be charged less than or equal to 4.8 days. So greatest integer function can be used in order to clarify how many exact days they will be charged on. So we have the greatest integer function of 4.8 days, which is 4. Therefore, the customer will be charged for 4 full days. Now, in order for you to practice what we have discussed, try to solve these expressions. And that's it. The greatest integer function is a simple but a powerful concept in mathematics. Remember, it always rounds down to the nearest integer, wherein n is less than or equals to x. Now make sure you practice more to its application. I hope you've learned something. Bye!